Okay, number 59. Got a new set of instructions. For the following exercises, use the function values for f and g shown in Table 3 to evaluate each expression. So if we look at Table 3, alright, first row is x values, second row is values of f with those x values, and the last row is the values of g with those x values. Okay, so we need to use the table to find these answers. Alright, so 59 is f of g of 5. So we need g of 5. What's g of 5? You look at the last row, find x equals 5 on the top row, and what's the answer? So when x equals 5, g of x equals 8. Alright, so that's the value you use, is 8. So now we need f of 8. What's f of 8? So we look at our table, find the x value of 8, and then in the next row is the f value. That would be 9. Alright, so that's the value. Okay, number 61. G of f of 3. Okay, find f of 3. So find x in the first row, 3, and then in the second row the f value is 8. Alright, so this becomes g of 8. And then for g of 8, find x equals 8 in the top row, right there. And then in the bottom row, the value for that is g of 8, which is 4. Alright, so that's your answer. Okay, number 63, f of 1. So find x equals 1 in the top row, and then what's the f value for that second row? That would be 6. Okay, so this is going to be f of 6. So for f of 6, you find x equals 6 in the top row, and the second row there is the f value. That would be 2. Okay, number 65, we have g of 6. So what's g of 6? Find x equals 6 in the first row, and then go down to the third row and get the y value, or the g value. That would be 7. Alright, so we want g of 7 now. So we find x equals 7 in the first row, and go down to the third row and you get g of 7 is 3. So that's your final answer. Okay, number 67, we have another set of directions here. For the following exercises, use the function values for f and g shown in Table 4 to evaluate the expression. So this is similar to the last one we did. Alright, we have a new table this time, Table 4. Okay, so 67 is f composed with g of 2. So the little difference here is they're using function composition notation here, f composed with g with the little open circle there of 2. So it's just f of g of 2, that's all it is. So again, just like before, you find g of 2 in the table. Find x equals 2 right there. And then g is the last one down there, the third row, equals negative 3. So that's f of negative 3. And for f of negative 3, you find x equals negative 3, and then right there is f of negative 3, which is 11. Okay. Okay, number 69, g composed with f of 3. So that's g of f of 3. So what's f of 3? So you look on your table, x equals 3 right there. F of 3 would be the second row there, negative 1. So that's g of negative 1. And then you find g of negative 1. Okay, so we look for negative 1. There's the x value, negative 1, in the table, and then go down to g. So that's 0. G of negative 1 is 0. So that's your final answer. Okay, number 71, we've got f composed with f of 3. So that's f of 3. So f of 3. Find f of 3. That's x equals 3 right there. F is the second row, so that's negative 1. Alright. Now what's f of negative 1? Find x equals negative 1 right there. And f is the second one down there, that's 7. F of negative 1 is 7. There you go. Okay, new set of directions for the 73. For the following exercises, use each pair of functions to find f of g of 0 and g of f of 0. So we have f of x is 5x plus 7. G of x is 4 minus 2x squared. So we want f of g of 0 first. Well, what is g of 0? Over here, plug in 0 right there. 4 minus 2 times 0 squared. Well, 0 squared is 0, and then minus 2 times 0 is 0, so it's just 4, right? F of 4. And what is f of 4? So plug in 4 in f of x here. 5 times 4 is 20, plus 7 is 27. So that's the answer for f of g of 0. It's 27. And then there's g of f of 0. What's f of 0? Plug in 0 right there in f. 5 times 0 is 0, plus 7 is 7, so that's g of 7. And what's g of 7? It's 4 minus 2 times 7 squared. So that's 7 squared is 49, so you've got 4 minus 2 times 49, which is 4 minus 98. And that's equal to negative 94. There you go. Number 75, we have f of x is 1 over x plus 2 and g of x is 4x plus 3. Okay, so we got f of x 1 over x plus 2. And g of x is 4x plus 3. So we first want to find f of g of 0. So that's equal to, well, what's g of 0? Plug in x equals 0 here. 4 times 0 is 0, plus 3 is 3. So we've got f of 3. What's f of 3? Plug in 3 into x here and f of x. 1 over 3 plus 2, that's 1/5. So that's it. Alright. And then we've got g of f of 0. What's f of 0? Plug in 0 here. 1 over 0 plus 2 is 1/2. So we have g of 1/2. And g of 1/2 is what? Plug in 1/2 right there for the x. 4 times 1/2 is 2. Plus 3 is 5. Okay, number 77. For the following exercises, use the functions f of x is 2x squared plus 1 and g of x is 3x plus 5 to evaluate or find the composite function as indicated. Alright, so let me write these functions down. F of x is 2x squared plus 1 and g of x is 3x plus 5. So we need to find f of g of x. What is g of x? It's 3x plus 5, so I'll write that in there. F of 3x plus 5. So you just plug in 3x plus 5, the whole thing into right there, into the x. So you've got 2 parentheses, 3x plus 5, quantity squared plus 1. Alright. So order of operations, say you do the powers before you do the multiplying by the 2 here, or adding. Do the adding last. So you square this. This is your familiar a plus b quantity squared is a squared plus 2ab plus b squared. So you've got a 2 here, and then you've got that squared, that's 9x squared, plus 2 times this times this. Well, this times this is 15x, and then 2 times 15x is 30x. So you've got plus 30x, and then finally plus that squared, the b, or the 5, so that's 25. Okay. So now you do the multiplying before you do the adding, so you multiply that through, distribute. 2 times 9x squared is 18x squared, plus from that 2 times 30x is 60x, and then plus from that 2 times 25 is 50, and then plus the 1. So now you simplify, add like terms, 50 plus 1. Alright, so you've got 18x squared plus 60x plus 51. And that's all the simplifying we can do on that one. Okay, number 79. Using the same functions as before, which I've kept on the board here, we want g composed with g of x. Alright, so g composed with g of x. That's g of x. And g of x is 3x plus 5, so I write that in there. Now g of 3x plus 5, you plug in 3x plus 5 and put that into there for the formula for g, right there on the x. So that's 3 parentheses, and you put in the whole 3x plus 5. And then plus 5. So there's your 3x plus 5, right? But the x is 3x plus 5. So distribute that through. 9x plus 15 plus 5 at the end there, and then add the 15 and the 5, so you get 9x plus 20. Okay, number 81. For the following exercises, use f of x is x cubed plus 1 and g of x is cube root of x minus 1. So let me write these down. F of x is x cubed plus 1 and g of x is cube root of x minus 1. Alright? So for 81, we need to find f composed with g of 2 and g composed with f of 2. So f composed with g of 2 is f of g of 2. Okay. So what's g of 2? Plug in x equals 2 here. 2 minus 1 is 1, so it's the cube root of 1, which is 1. Alright. Now we need f of 1. What's f of 1? Plug in 1 right there. 1 cubed is 1, plus 1 is 2. So it's as easy as 1 plus 1 is 2, isn't it? Alright. So there's your final answer for that one. And then we have g composed with f of 2. So that's g of f of 2. So what's f of 2? Plug it in there, 2. 2 cubed plus 1, that's 2 cubed is 8, plus 1 is 9, so it's g of 9. And what is g of 9? Plug in 9 right there. 9 minus 1 is 8, and the cube root of 8 is 2. Well, same answer. All right. Okay, number 83. What is the domain of f composed with g of x? Well, what is f composed with g of x? Let's get that first before we can answer this. So that equals f of g of x, and that's f of cube root of x minus 1. And that's, you plug cube root of x minus 1 right there. When you take, well, let me write it out. We've got cube root x minus 1 cubed plus 1. So that's f of cube root of x minus 1. Alright, so you're taking the cube root and then you're cubing it, so what you get is just x minus 1. So it's like writing x minus 1 in parentheses to the 1/3 power. 1/3 power would be cube root. And then you've got cubed on the outside, so you multiply those exponents and you get 3 times 1/3 is 1. So it's just 1 power. So you got x minus 1 plus 1, and that's just x. Negative 1 plus 1 is 0. Alright? So, well, what's the domain of x? Well, it's all real numbers, okay? All real numbers. And that would work here before we simplified as well. Okay, so you can take the cube root of anything, any real number. So the domain is negative infinity to infinity. If you may have noticed that f composed with g is the identity function. Remember the identity function? I of x equals x. In other words, anything you put in here, you get back again, the same value. Alright? You'll also find that g composed with f of x also gives you the identity function. Right? If you want, you can try that. And if that occurs when you have it both ways, giving you the identity function, then these functions are said to be inverses of each other. Alright? Inverse functions. So it's like a multiplicative inverse. For example, 2 times 1/2 is 1, and 1/2 times 2 equals 1. So the multiplicative inverse of 2 is 1/2, alright? And the multiplicative inverse of 1/2 is 2, because you always get 1 when you multiply those together. Okay? So there's a similar situation with function composition. Alright? Okay. Okay, number 85. Let capital F of x equal the quantity x plus 1 to the 5th. Lowercase f of x equals x to the 5th, and g of x equals x plus 1. True or false? G composed with lowercase f equals capital F of x. Is that true or false? Well, let me write these down. Capital F of x is x plus 1 to the 5th. And lowercase f is just x to the 5th. And g of x is x plus 1. So what we want to know does, or is, g composed with f of x equal to capital F of x. Well, let's find out what g composed with f is. G composed with f of x is g of f of x, and that's g of, what's f of x, lowercase x to the 5th, g of x to the 5th, and put it in there, x to the 5th plus 1. Alright, Now, does this equal that? In other words, x plus 1 quantity to the fifth, does that equal, I'll put a question mark over that, x to the fifth plus 1? No. If this were squared, you'd know what that is, right? You know it's not x squared plus 1 squared. Yeah, even if it's a fifth power, it's not equal to this, right? You can't distribute that power in here, right? So when you have a plus or a minus, so when you have more than one term in there, you can't just multiply the power like it was a number in the front here and use a distributive property. That's not how powers work, okay? So the answer is false, okay? No. All right. So in general, a plus b to the n does not equal a to the n plus b to the n. Okay, so in some cases that works, like if n is 0, or no, that won't work, will it? No. 0 won't work because here you'd have 1 plus 1 is 2, right? And this would be 1. 1, if n was 1, that would be okay, right? That's the only way it's going to work, if n equals 1, all right? So if n is anything else, it's no good, all right? Now it also works for fractional powers. We talked about this before. If n is some fraction, the same thing applies. So if you had like the square root of a squared plus b squared, that does not equal a plus b. Alright, in other words, square root of a squared plus b squared is a squared plus b squared to the 1/2 power. And you can't distribute the 1/2 through there, alright, and get a plus b. Alright, it's not, doesn't work. So if that's a plus or a minus in there, just leave it be. That's the way you, that's what it is. You can't go any further with that, alright. So be careful of that. This mistake seems to affect people a lot more than this one over here, alright, because we see this one a lot, more often at least, but this one, it's the same principle. Just remember, it's a 1/2 power instead of the 5th power. So yeah, it still doesn't work, alright. You can use what's called the binomial theorem and get what x plus 1 to the 5th does equal. And I'm not going to go over the specifics, but this is what it equals. X to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared plus 5x plus 1. Okay, so that's a far cry from x to the 5th plus 1. Alright, that's what it actually equals. And you can use what's called the binomial theorem. It's a formula. A lot of math reference books have that in there. Our book might even have it. I don't know. I didn't bother to look. But yeah, you can find it in a lot of math books. And you can just follow the formula. And no matter what this power is, some integer power, positive integer, you can use the formula on that and get the expansion of that without having to multiply everything out. Okay. All right. Okay, number 87. For the following exercises, find the composition when f of x is x squared plus 2 for all x greater than or equal to 0, and g of x is square root of x minus 2. So f of x is x squared plus 2 for all x greater than or equal to 0. This upside down capital A means for all. That's another symbolic logic abbreviation or symbol. Okay, a lot of mathematicians like to use that because it maintains your brevity there. G of x is square root of x minus 2. Okay, so 87. What's the composition we're looking for? F composed with G of 6 and G composed with F of 6, alright? So F composed with G of 6. Fog of 6, right? Haha. No, don't use that terminology. F composed with G of 6. I'm going to give you bad habits here, don't do that. F of G of 6. And that's equal to F of, what's G of 6? 6 minus 2 here. 6 minus 2 is 4, square root of 4 is 2. So that's F of 2. Now, is F of 2 defined? Because we have a condition here for all x greater than or equal to 0. Is 2 greater than or equal to 0? Yeah, so we can use this function, it's defined. So you plug in x equals 2 there, 2 squared is 4, 4 plus 2 is 6, alright, so finally we get 6. And then we have G composed with F of the same thing, 6. And that's equal to G of F of 6 and that's equal to, what's F of 6? Let's see, put 6 here. 6 times 6 is 36, 6 squared. 36 plus 2 is 38, so it's G of 38. And then plug in 38 and G here. 38 minus 2 is 36. Square root of 36 is 6. Ah, there we go. Makes me wonder if these functions are inverses of each other. All right. Okay, number 89. We want F composed with G of 11 and G composed with F of 11. Alright, so F composed with G of 11 is F of G of 11. What's G of 11? Plug in 11 here. 11 minus 2 is 9, square root of 9 is 3, so we got F of 3. Now, is F of 3 defined? Look at this condition. Is 3 greater than or equal to 0? Yeah, sure. So, you can use this formula then, it's defined. So, what's F of 3? That's 3 squared is 9 plus 2 is 11. Alright? And then we want G composed with F of 11. So that's G of F of 11, and that's G of, what's F of 11? Is F of 11 defined? Yeah, it meets the condition, so plug it in. 11 squared is 121, plus 2 is 123, so G of 123 is what we're looking for now. And then plug it in here. 123 minus 2 is 121, square root of 121 is 11. Alright, there we go. Okay, number 91. Wow, we're in the 90s. Ooh-wee. Okay, The function capital A of D gives the pain level on a scale of 0 to 10 experienced by a patient with D milligrams of a pain-reducing drug in her system. The milligrams of the drug in the patient's system after T minutes is M of T. Which of the following would you do in order to determine when the patient will be at a pain level of 4? Okay, let's see if we can understand this. Capital A of D. That's the pain level. Alright, and it's on a scale of 0 to 10. So, in other words, A of D is between 0 and 10, and that would be inclusive. So that's how you would write that mathematically. A of T would give you a value between 0 and 10, including 0 and 10. Okay. And the milligram of a drug in the patient's system is M of T. Alright. So M of T is let's just say the amount of drug in the system at T minutes, time T minutes. Alright. Now D, little d, is in milligrams. So I'll write milligrams of drug. And M of T is milligrams of drug, right? Now T is not milligrams, it's time in T minutes, right? So this is time. M of T will give you the milligrams of the drug in the system when the time is T. And capital A gives you the pain level between 0 and 10, depending on how many milligrams of drug, whatever this drug is, in the person's system. So it looks like you could form a composition. You could take, since this gives you milligrams of the drug, you can plug it in there. A of M of T, right? A composed with M. And that'll give you the pain level, which at a certain time T minutes after they take the drug. Okay, so A of M of, let me just write that down. A of M of T is pain level that's T minutes after taking the drug. Alright, does that make sense to you? Okay, so M of T will give you the amount of drug in the system at time T, minutes after you take it. And so this is in milligrams. And A can handle milligrams, right? A wants milligrams of drug. So A gives you the pain level between 0 and 10. Alright, so when you form this composite function, what you get is a function, a new function, which will give you the pain level T minutes after you take the drug. Alright. Okay, well, now that we understand this a little better, see, when you have problems, these word problems, it helps to write down what you know, take stock of what you know, organize your thoughts, and think it through. What do I have here? What do I actually have? When you write it down yourself, instead of just reading it, It forces you to think it through, right? So write it down. Don't just try to do it all in your head, unless you know, you've seen a lot of these problems before and you're used to them. If you're not used to it, write it down step by step, like I did here, and it'll clarify your thinking, all right? And then it'll enable you to answer the question very easily, usually. So it says, what are we supposed to do? Which of the following would you do in order to determine when the patient will be at a pain level of 4? When? So the wording here is got to be taken into account. What would you do to find out when the patient will be at a pain level of 4? So we are looking for a function that will give us the amount of pain level 4, at a certain time t. All right? When? So if you look at the multiple choice here, part A, evaluate A of m of 4. Right? Part A. Is that going to work? A of m of 4. Well, now they said 4 is the pain level, right? But here, m takes time, right? T minutes after you take the drug. So that wouldn't apply, right? We're looking at a pain level of 4. A gives you the pain level, right? It's between 0 and 10. So that's not going to work, all right? B. We have m of A of 4. Well, what this is, this isn't going to work because, well, first of all, the 4 is a pain level that they gave us, all right? But A takes milligrams of drug. You're supposed to plug in a milligram here, and A will give you the pain level. But you're using the pain level as the milligrams, which doesn't quite work, all right? So A of 4 gives you a pain level, but M, now M again takes time in minutes after you take the drug. That's not a time. It won't give you a time, right? So this is no good, all right? What about C? A of M of T. Solve that, all right? You want to find out when you have a pain level of 4. If you solve this, that'll tell you when you'll have a pain level of 4. Is that correct? Yeah, this looks like the answer that we want. Remember, A of M of T gives you the pain level T minutes after you take the drug. All right? So you set A to 4 because that's the pain level you're looking at. They gave you 4, pain level of 4. So A gives you pain levels, right? So what you do is you set this function equal to 4 and you solve for t. All right? Now presumably they'll give you formulas for A and M. They didn't do it in this problem. All right? They could have, and it would have made it even more interesting. All right? But they're having a little mercy on you here. But yeah, if they gave you formulas, you could actually solve that for t and find out when this person has a pain level of 4. All right? Well, we know this is going to be the answer, right? That works. I'm assuming only one answer is correct, but let's look at the last one just for kicks. Solve A of D equals 4. Oh, M of A of D. M of A of D. If you solve that, are you going to get what you want? Well, A of D gives you a pain level. Once again, this is a pain level, not a time. M takes the time levels, times, after you take the drug. So A of D gives you a value that wouldn't work in M. All right? In other words, A of D is not in M of T's domain. All right? So it just doesn't fit. All right? So the answer to this is C. Okay, number 93. A raindrop hitting a lake makes a circular ripple. If the radius in inches grows as a function of time in minutes, according to r of t equals 25 square root of t plus 2. Find the area of the ripple as a function of time. Find the area of the ripple at t equals 2. Alright. Oh, this reminds me of problems in related rates in calculus. You'll see what they are. But yeah, this is probably practice for that. So we have r of t, lowercase r of t, is 25 square root of t plus 2. And that's the radius in inches, which grows as a function of time in t in minutes, according to r of t equals, okay. So, for example, in t minutes, it'll give you the radius of that circular ripple in t minutes, alright? So, there you go. Find the area of the ripple as a function of time, and then find the area. So, let A equal area of the ripple, alright? Define your variables here. I'll use capital A. Alright. Now, we're dealing with a circular ripple. So, what we want to do is find the area of the ripple, in other words, the area of the circle. Alright. So, area is pi r squared of a circle, right? Area is pi r squared. Okay. So now, what we want is area as a function of time. Now here, this formula, which is the famous formula that you should have memorized, this is a function of radius, alright? It's got r in it. It's got pi as well, but pi is a constant. Okay, but the variable here is r, so it's area as a function of radius. In other words, you plug in the radius and it'll give you the area. But we want an area as a function of time, alright? At time t, what's the area? So we need to convert this into a formula involving a function of time for radius. Now they gave us this formula right here. So a of t then, this is now a function of t instead of r. That's what we're doing. We want a of t, that's pi. I'm using pi r squared, except for r I'm using this formula here. Alright. So that's 25 square root of t plus 2 squared. So pi r squared. Alright. So when you square this out, you get 25 times 25 is 625. And then you square that part, you're going to get t plus 2. And then you're going to get pi there. So that's 625 pi, and then t plus 2 in parentheses. Alright, so there's a formula for area as a function of time. So then it says, what's the area of the ripple at t equals 2? Apparently it's 2 minutes. Okay, so a of 2 is what we want. Plug in t equals 2 right there. So you get 4, 2 plus 2 is 4, times 625 is 2500, and pi. So 2500 pi, and the units here they gave as, well, the radius was in inches, right? So when you square that, you'll get square inches. So this is going to be square inches, which makes sense. Area should be a square inch and not just inch, right? So you punch that into a calculator and you get a decimal approximation, or approximation for this. 7854 is what I come up with. 7,854 square inches. Okay. Okay, number 95. It says, use the function you found in the previous exercise. That would be 94. Huh, I thought they only gave us the odds here. to find the total area burned after 5 minutes. Well, now we have to do 94, don't we? And there's no answer in the back of the book, is there, for 94? So you're going to have to trust me on this one. All right. So we get a bonus problem here, don't we? All right. 94 says, a forest fire leaves behind an area of grass burned in an expanding circular pattern. Sounds like the ripple problem we did. If the radius of the circle of burning grass is increasing with time according to the formula R of t equals 2t plus 1, express the area burned as a function of time t in minutes. And again, we do it the same way as we did the last problem, 93. Okay, so it's the same kind of a problem. Use a equals pi r squared, but for r use 2t plus 1. So we get a function a of t is equal to pi times 2t plus 1 quantity squared. So that's our area function in problem 94, okay? All right. Now what do we want? Oh, let's see. Find the area, total area burned after 5 minutes. So what you want to do is find a of 5. So you plug in t equals 5 right there, like I did here. And you're going to get 10 plus 1 is 11, and then 11 squared is 121. All right. So again, order of operations, do what's inside the parentheses first, and then you square it, and then you multiply. So you've got 121 pi. That's going to be in, let's see what units. Does it say in 94? It talks about the radius of the circle, but it doesn't say what units they're using. Uh-oh. They really should specify the units here. That way we can say this is going to be in square inches or square feet or whatever it is. But they don't specify the units in 94. So we just have to say square units, okay? We don't know what the units are. Don't assume anything. I mean, you know, in real life, if you were to get this, you would have to just use square units because nobody specified what the units were to you, right? So don't assume anything unless you're very familiar with the field that you're in and you're familiar with the units that they always use, all right? So anyway, that's about, plugging that into a calculator, 380 square units. I'll just write square as SQ units. Square units. Okay. Okay, the last problem, and it's kind of big. It's a multi-part, A and B. But it's the last one. How about that? Put that in your pipe and smoke it. Deal with it. All right. The number of bacteria in a refrigerated food product is given by capital N of T equals 23t squared minus 56t plus 1, where t is between 3 and 33, and T is the temperature of the food. When the food is removed from the refrigerator, the temperature is given by capital T of small t, which is 5 small t plus 1.5, where t is the time in hours. Okay, let me write this down. We've got N of T, capital N of T, and that's capital T there, not lowercase t, all right? So that's 23 capital T squared minus 56t plus 1, and the domain restriction is between 3 and 33. So that's the domain of capital N, all right? T is temperature of the food. And let's see, n, let me write that down, where n is number of bacteria and T is the temperature of the food. So I'll just write food temp. Okay. So you take the food out of the fridge and the temperature is given by T of T, capital T of lowercase t, which is 5 lowercase t plus 1.5, where lowercase t is time in hours. Okay. Part A. It says find the composite function n of t of t. N of capital T of lowercase t. Alright. That equals, well, what are we going to get? We will get a function which gives you the number of bacteria T minutes, the bacteria in the food that is, T minutes after you take it out of the fridge. Alright, so that could be useful. This function gives you the bacteria and where T is food temperature. Alright, so maybe this is more useful to us, this one we're coming up with. What is capital, let's see, capital T of T, that's, where is that? Over here. Okay, that's 5t plus 1.5. Okay, this is going to be a little bit nasty. Plug in 5t plus 1.5 there, and then simplify. Alright, so we've got 23 times the quantity 5t plus 1.5, and then we're squaring that, and then subtracting 56 times 5t plus 1.5, and then plus 1. Alright. So now, square that out. Alright, so we've got a squared plus 2ab plus b squared, right? So that's 25t squared plus 15t plus 2.25. And then minus, you can distribute the minus 56 through here. Alright, so that's going to be minus. Now remember, both of these signs are going to change to negatives. Alright, so it's going to be what? Minus 280t, and then minus 84, and then the plus 1 at the end. So now you can distribute this through and then add like terms. Alright, I'm going to skip a lot of details here and go right to that, and then simplify. So you add like terms, first you multiply that through, right, and then you add your like terms. Looks like you're going to have a 30t, and then you can subtract from that 280t, and then you can have minus 84 plus 1 is minus 83, and then you can add that to that. 2 times that is 5, right? Not quite 5. So anyway, multiply that through, right? So you're going to get 575 t squared plus 65t minus 31.25. Alright, well that's the answer then for part A. Okay. So I'm going to have to make some room here for part B, but there's part A. So let me erase part A quickly here. Okay, part B. Part B. Find the time, round to 2 decimal places, when the bacteria count reaches 6,752. All right. So we use the function that we just came up with in part A. That gives you the number of bacteria after time t has elapsed. All right. And we have to set that equal to 6,752. So let me do that. 575t squared. This looks like a calculator problem, but you can do this by hand, which I will do. 65t minus 31.25 equals 6,752. Alright. Subtract 6,752 from both sides, so you get 575t squared plus 65t, and then minus 6,783.25 equals 0. Alright, so now we can use the quadratic formula to solve this exactly. Alright, so t then is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, right? So a is 575, b is 65, and c is negative 6,783.25. Alright, so plug it into the formula. And we got plus or minus square root of b squared minus 4ac, that's 575. And then minus 6,783.25 all over 2a. Okay. So that simplifies to negative 65 plus or minus, and then I'm going to just, you can plug that into a calculator and get the result. That comes out to be 15,605,700. 2 times 575 is 1150. Okay, so now t, if you use minus here, plus or minus, there's 2 answers, right? One is going to be a negative answer. If you use that minus sign, that'll be a negative result. We don't want negative t. T here is supposed to be positive, so we'll use the plus, just the plus. So we're only going to consider the positive result. Alright, so I'm going to write, let's see, where can I do this? Negative 65 plus the square root of 15,605,700 over 1150. That's the only one I'm going to consider, and that's roughly or approximately equal to, if you plug all that in a calculator, so the numerator becomes about 3885 0.4050 4252 using my old trusty HP 28S, and that's over 1150. Now when you do this step, this part right here, don't round that to 3885 over 1150, alright? Because you're not done yet computing. And if you're using a calculator, which I'm sure you are, I did, don't round that off. Leave that the way it is in your calculator and then divide that by 1150. Because if you round it off here and then you round that answer off after you get to the end, you may have a very inaccurate result. Okay, so you want this to be as accurate as possible when you're using a calculator. So don't round until the very end, okay, if you can help it. So this is about 3.38. So that's in hours. So about 3.38 hours. And that's when you're going to have 6,752 bacteria in the food after you've taken it out of the refrigerator after a little over 3 hours, 3.5. A little over 3.5 hours, you're going to have that many bacteria. Well, we've done yet another section here. We're completed. Now you can relax, maybe, I hope. Unless you've got more homework to do. I hope you don't. I hope you're all done, and I hope you can take a break, take a little breather, have some whatever it is you drink. Alright, and stay tuned for the next installment of the this highly beautiful mathematical series. Alright, so I will see you soon. Take care.